Hi there, I'm Leonardo, a backend developer at BIX. And in recent years, I've learned that there's a huge difference between code that works and architecture that scales. I will show exactly how we think about every detail of Contentful to support not 1,000, but 100,000 simultaneous users. And this is where many developers go wrong from day one. You must have seen a system that worked perfectly until the day it didn't anymore. Content flow was running smoothly, 10 users in fast processing, everyone was happy. Then Monday came and boom, 1,000 users trying to upload simultaneously, the system crashed, users are furious, and my startup is almost dying. Let's talk in real numbers. Most developers think like this. I will create a server, put in a simple function, and if it grows, I'll scale it later. The result? A disaster waiting to happen. With 10 users, the system works. With 100 users, it starts to slow down. With 1,000 users, it's a timeout on a dead system. Because architecture is not something you add later. It's like the foundation of a building. Either you do it at the beginning, or the system will collapse. At Contentflow, we had a very specific challenge: heavy video processing. A 1 gigabyte file can take up to 10 minutes to process. Multiply that by 1,000 simultaneous users, and you have the problem of 10 minutes of parallel processing. The traditional server died in the first week. Here's the solution for that. It's not magic, it's engineering. Let's start from the principle of separation of responsibilities, where each service does only one thing, but does it well. The API gateway receives the request and handles authentication. The upload service is responsible only for receiving the files. Process service processes the videos. Notification service, only the notification service. Storage server manages the files. And why separate? Because when the upload stalls, the site's processing keeps working, crashing our system. This is our second little secret to handle many uploads without crashing: a system of intelligent queues. At first glance, it might seem a bit confusing, but think of this system as a modern and busy cafe. You arrive at the counter and place your order. This will be the upload. The attendant doesn't stop everything they're doing to prepare your order. They write it on a cup and place it in a line of baristas. This line of cups is our queue. The important thing is that the cashier is already free to serve the next person. The system wasn't occupied by you until the end. The baristas will take the cups from the line and prepare our drinks. These are our workers. They process the orders one by one. And when the coffee is ready, it goes to the counter. This will be our counter. But what now? What if a group of 50 people arrives all at once? In the coffee shop, the manager sees that the line of cups is growing and calls more baristas who were in the stockroom to... In our system, it's exactly the same thing. If the upload queue starts to grow too much, the system automatically calls more workers to process everything faster, ensuring that the experience is never too long. This way, whether the user is first in line or the 1,000th, they will never have a very long wait time. So, with our cafe, we solved the problem of having thousands of orders at once. But that's only half the story. What happens after these videos are processed? When the coffee is ready, where is it stored? And most importantly, how do we ensure that thousands of people can get their coffee, or rather watch their video at the same time, without everything becoming very slow? This is where our second strategy comes in, a distributed database. Let's separate the strategy intelligently, starting with the primary server, which is where it receives the critical kits, like the link to a new video. Then, we have several replicas, which are exact copies and handle all the red queries. When 10,000 users try to access a video, these replicas will come into action. Next, we will have the cache, which we will use to deliver the most... Okay, we have a powerful structure. But remember our cafe manager who called more baristas when the line grew? This magic doesn't happen on its own. Our system needs a digital manager that makes decisions based on real-time data. And that's what we call intelligent autoscale. If the CPU is over 70% usage, call more workers. If the queue has more than 100 jobs, double the capacity. Is the traffic low? Automatically reduces costs. And how does our digital manager know the right time to act? He doesn't guess. Keeps an eye on a control panel 24 hours a day, 7 days a week, ensuring everything is operating as it should. Right. Putting all this together, an intelligent queue system, an already distributed database that delivers information very quickly, and an autoscale that manages monitoring resources, ensuring system health. What is the practical result of all this engineering? We have 1,000 simultaneous videos running, 10 gigabytes of parallel upload working without crashes, 99.9 uptime guaranteed, a linear cost where you only pay. We simulated a real stress test. The monolith crashed with 50 users. Our architecture handled 5,000 users. 100 times more performance. Now the crucial question, will the system handle success? Because this is the truth no one tells you. A large part of startups fail because the system can't handle it when their users arrive. You can work all over the world, but if it crashes when 1,000 people try to use it at the same time, it's game over. If you're building a SaaS and want to ensure it will scale from day one, or if you already have a system that's starting to have performance issues, I have a proposal. Our team at BIX not only masters distributed architecture, but also knows exactly how to implement it without blowing the budget or the deadline. And in the next video, Vinicius will show you how to turn all this technical complexity into an interface so simple that anyone can use it. You will see how smart design can be the difference between success and failure. And until then, remember, code that works is good. Architecture that scales is gold.